See, now it's baking again. I can feel that heat. Okay, so number one. Oh wait, I can't go over this right now because I just sent this to the online. Oh, so I can't. I can't just like have them working it out with us at the same time. Although they can still cheat on it, I guess. But I don't want to like. I don't want to force them to cheat. I'm going to get back on and take it out. I can't do it. I'm boiling. So yeah, you need to know sine squared and cosine squared. I think I'll go over this tomorrow. So what kind of questions do we have? On anything. Not on the quiz, but on anything else. Yeah. We're gonna have a test today? Yes. We're gonna talk about that in a minute. I'm always confused with placing negative right when there's a negative part of mine. Because like when I put the negative in, it's always different. Yeah. Okay, give me a specific example. So on 197, easy. So then like I have 2 natural logs of x to 4 plus natural log of x. Give me the problem. Oh, okay. The antiderivative of 3x over x plus 4x minus 2. X plus 4x minus 2? Yeah. Not 2 minus x. Not 2 minus. Okay. So if we're going to do this with partial fractions, so I'm going to break this up. Like that. Okay. Now I got to figure out what A and B are. Now, can you use a shortcut on this? The answer is yes, you can, because those are the only ones that we're going to do. I don't know if you guys saw that. But if I make the decision, we're only going to do those. Which really makes things a lot easier. So can you use a shortcut on this? Yes, right? So let's figure out what A is. So A, negative 4 makes that 0, right? So I cover this up and I say 3 times negative 4 is negative 12 over negative 4 minus 2 is negative 6. So that's A. All right, which, yes, that ends up being 2, which we'll do in a second. Now, B, so I say 2 makes that 0, so 3 times 2 is 6 over 2 plus 4 is 6. That's 1, I guess. So we're good there? So this ends up being 2 over x plus 4 plus 1 over x minus 2. Now we can do this. So this ends up being 2 natural log of x plus 4 plus 1 natural log of x minus 2. All right? Yeah. And that's not what the back of the book has? It has 2 natural log of x plus 4 and then minus natural log of 2 minus x. Why would they do that?
They did that on a lot of problems. Like
That's
they
stupid.
switched the x and do like they made x negative.
And you're telling you're for sure that this was the yeah, I don't know what's wrong. Don't do that. I mean, that's creating more work. I was expecting you to tell me that this is what they had to do. Where's that come from? So you first can deal with this 2 in front to make that squared. And then if you have the sum of 2 logs, that's the same as the log of the product. Those properties of logarithms. Yeah, you did it right. I'll make it harder. Now, if that were 2 minus x, then we would want that negative there. Yeah.
Are we have to know the long way for the exam? Or
For the test? No. But you can use the shortcut. Yeah. What is it?
It's either x.
Oh, so yeah, these I remember, yeah. So e to the x over, so this is a partial fraction problem, but it's in disguise. Okay? This is a partial fraction problem, but it's in disguise. The first thing that we're going to do is is that true? I'll just throw it over there somewhere. Things too. So I factored out an e to the x there. Maddie, what's the deal? That's exactly what we're going to do. Yeah. So now, once I factored out that e to the x, I'm going to do a u sub here. And now it's going to become this. 1 over u times u minus 1 du.
Why is the numerator 1 not another u?
Why is the numerator 1 and not u?
Yeah.
Because the numerator is really du.
Okay,
You see that?
I guess.
That doesn't sound confident.
Well, why is that the dx? Because it's a dx and not a u the other one.
Say that again.
There's 3 e to the x's there. How come that's the one that's with u?
Because this e to the x in the numerator, the original problem really could be thought of like this. I got e to the x dx over e to the x times e to the x minus 1, right?
So the other ones are being divided by dx.
The other ones are what?
Are underneath. The x is in the
Yeah, so like this right here is getting replaced by du.
Okay.
That makes sense?
Yeah.
Okay, so now can you partial fraction it? A over u plus b over u minus 1. So what's a? 0 makes that 0. Cover that up. So 1 over 0 minus 1 is negative 1. And then 1 makes that 0. So 1 over 1. So this is negative natural log of u plus natural log of u minus 1. And now go back and resubstitute. That's negative natural log of e to the x plus natural log of e to the x minus 1. And does this simplify? What's negative natural log of e to the x simplifies to? Just negative x. The other two that were in that section, I think there were a couple other problems right after that one that were like sign involving trig functions. They're almost done the exact same way. You factor out and then do a u sub. Those are partial fractions in disguise. Sure.
Sine of x over 1 minus x squared.
So this one you don't even have to factor, actually. Sine of x over 1 minus cosine squared of x, right? So you have two options here. You don't have to do partial fractions on this problem because you could just say that's sine of x over sine squared of x, right? Because 1 minus cosine squared is sine squared. Simplify that, and now that becomes 1 over sine of x, which becomes cosecant of x, right? And what's the antiderivative of cosecant of x?
Negative natural log of cosecant.
Plus chips, right? So we could have done it that way. But we could have also done it where I said, okay, let's let u equal cosine of x. What's du? Negative sine of x dx, right? So that's negative du over 1 minus u squared. And then that's negative 1 over 1 minus u times 1 plus u. And then I forgot du. And now you can partial fraction this. A over 1 minus u, b over 1 plus u. So what's a? So use the partial fractions there. What's a? So, well, what makes that 0? 1, right? So 1 over 1 plus 1, 1/2, right? All right, now what's b? So negative 1 makes that 0. So 1 over 1 minus negative 1. 1 minus negative 1 is 2. So positive 1/2. Do I agree with that? Okay, so now we anti-differentiate this. But remember we got to negatize this. So whatever we get, we're going to negatize. So what's the antiderivative of this first term? Be careful. The antiderivative of the first term is negative 1/2 natural log of 1 minus u. Why is that negative there? There's a little substitution that you're doing. There's a little u substitution. Now I guess we wouldn't use u because we already have u in here. But that, because that's 1 minus u, the derivative of that is negative, right? That's what's causing that negative right there. Plus 1/2 natural log of 1 plus u. Right? So then if I distribute that negative on the outside here, that's going to be 1/2 natural log of 1 minus u minus 1/2 natural log of 1 plus u. Yes? Doesn't look like a plus on there. Go back and resubstitute. What was u? Cosine? This should be minus. Did you guys see that? Yeah.
Okay, so when you distribute the negative, it changes like inside.
Yeah, so this one here should be minus becomes plus. Oh, I wrote these backwards. I see what I did now.
Okay.
Yeah, let me rewrite that. Sorry. I'm going to distribute this negative. So that's going to be 1/2 natural log of 1 minus u, then minus 1/2 natural log of 1 plus u. Now resubstitute what would you use? So I think I have a sort of a bigger issue here. Anybody know what my issue here is? We did this 2 different ways, correct? Those answers don't look at all similar. Like, this is the negative natural log of cosecant plus cotangent. And you're telling me that's equal to this. Are those equal to each other? That's like a perfect trig identity proof, right? And you could have done that. You could have had that problem last year in pre-calc. Show me that these two are equal. They have to be equal, or they have to differ by a constant. They have to be equal or differ by a constant. Otherwise, we screwed something up big time. And I don't think we did. I mean, this is right. Sine squared, or 1 minus cosine squared is sine squared. Sine over sine squared is 1 over sine. That's cosecant. I mean, that's right. And this substitution here is right. Now, I did screw up that distributive property that I always thought, but I actually think I didn't screw it up. I wrote it the right way, but my handwriting was bad, and I thought I wrote something else, and then I corrected it, and when I corrected it, I actually made it wrong. But that was my fault. So are those equal? Might be fun to sit down and try to prove that. How would you prove that? You know what I would do first? Is I would write it like this. Right? And then I would go from there. One half is kind of bothersome, but it's going to come out in the wash though. What's that 1/2 mean in terms of when it's out in front of the wall? Like to the power. So really, this is the same thing as this. Yeah? And this over here is the same as this. Yeah? So realistically, I need to show that and that are the same. Think you could do that? Anybody think they could do that? You should be able to do that. I mean, maybe not right now with the gun over your head, but You guys remember doing stuff like that last year, proving those identities like that? Nothing. Emmy's looking at me like I have two heads. Because I think that's what a two-headed one. You do something? What? Snyder did do it? Bridges did? You don't remember proving identities?
No, we did that, but not this part.
Oh, you guys are making that sound like that's a lot harder than it is. What? 1 over, what does that say? Cosecant x plus cotangent x equals the square root of 1 minus cosine over 1 plus sine. And that's what you have to show is equal. Oh, sorry. No one remembers something like. Yeah, I mean, I don't know, like, where we are right now, I mean, I have not worked this out, so I don't know what the correct strategy is to go about. I mean, I can think of 2 ways to start this. If I were going to work on the left side, I would probably find a common denominator in the numerator and the denominator, and then go from there. If I were going to work on the right side, I'd probably multiply by a clever form of 1. What's the clever form of 1 that I would use? I'd probably do 1 minus cosine x over 1 minus cosine the conjugate. So that's going to turn that bottom into sine squared. I give like some bonus points if somebody gives it to what? Yeah. Time we get out of here? 41. Soon. Oh my God. Other questions? So, I think that we are going to have a test a week from today. There is no way that we can have a test this week because of the shortened schedule periods, and that would be laughable. So tomorrow and Wednesday we will deal with improper integrals, which is always thrown into this unit for some reason. It doesn't really fit with the other stuff, the techniques of integration, but we'll throw it in there. But I think we'll have a test on Monday over all of these techniques. So we have integration by parts. Well, you have U subs, integration by parts, trig subs, partial fractions, and then improper integrals, which is but we'll have a partial fraction quiz tomorrow. Since you guys said we need more quizzes. That's what I heard. He said you needed more quizzes. So Dell and Gavin said. So that quiz tomorrow will just be like a quickie. I mean, right? I mean, because these partial fractions, if you're using the shortcut, the problem literally could take 45 seconds. Right? And then after we do that, we'll start improper intervals. Does that sound good? We're a little behind where we should be, sadly. But it's Wednesday in the middle of the week. I'm having a hard time figuring out how to use that the right way. You wouldn't even know we were behind if I didn't say we were. So, yeah, I don't know. What else? Anything good? There's lacrosse tryouts today? I was gonna say, do they cut?
Yeah, I don't know, they test every 5 girls out. There's a lot more girls signed up this year.
Oh.
I'm there for the skills, because I've never played before. But I know how to run around and
I mean, how many kids show up to lacrosse tryouts and have ever played lacrosse before? It's gotta be like 4.
I'm not like good.
So you're just gonna, you've never played, you're trying out again? Or you're trying, so this will be your second, like, right before your senior year?
Yep. I figured my
Why not? What else is there to do?
right.
Run track, I guess.
Yeah, I did.
Softball. Somebody here's a softball player. Who's a softball player? Isn't somebody in here? Are you a softball player? Oh. Is your little profile picture on like in Zoom of softball? Yeah, I remember a softball. I can picture the screen with all of your pictures. I remember a softball. That's why I said somebody here's a softball player. All right. Well. Good luck. Swimming is good. Yeah.
What's after this?
State. No, I mean, our relay, we can go probably 150 next state, maybe.
Yeah.
Rachel goes next state, you have to go 58. Oh.
Right, it's when I was told that I'm not doing that, like, I'm sorry.
Yeah.
That's what I was doing. I was like, I don't need this. I'm okay with it.
Did Chad ever come back in here?
That's hard.
Oh. Oh, wait. Yes, you do. Easy.
Is it?
Are you talking about for Will or Joe?
Well,
Um,
so, when you have time, these are the things that I have no clue how to answer because I don't know enough about it.
it's not available just.
Okay,
Nothing is available to. No, none of our classes are available to only one grade.
okay.
Um,
But I didn't know how to answer the,
yes. I mean, VC is the harder class
right,
by far. Not even close.
okay, I knew
Or
that.
1 and 2 is the harder class.
1 and 2?
Yeah, Calc 1 and 2.
What's it called?
Calc 1 and 2.
It's called Calc 1 and 2 now.
Yeah, and this
Okay.
this really is still. I'm not sure how they ended up going with it. Like we debated back and forth if it's still called Calc AB or not.
Okay,
Um,
I'm assuming she's looking
but
at
Calc
that.
AB is just Calc 1.
I knew that because I talked to Glendon yesterday,
Yeah.
Friday when you weren't here. So I knew that, but I didn't know the AP status and what that did to it.
It's
I
not.
just
It's,
didn't.
I mean, it's not really AP. per se. I mean, they call it credit for it when you do it's they're both CCP.
Okay, I knew that, I verified that as well. I don't ever remember.
I mean, honestly, I would say.
Oh, you submitted it. Which one?
They're both,
Have you looked
yeah.
at your-
I don't know why you asked me in the first place. Really?
No, it wasn't.
You got that. We did, 1.3 on the test.
Where is the institute upstairs? When you get to the institute, I could be second. Like the second and the third. Hello. That's why I can't wear myself. But I just was irritated this morning. I know, one day I wanted to, because I was literally in the podcast. But then I was like, what, I can't. Yeah, I was like, because I woke up and there was just a little itchy on me. I'm like, really? I got very good. I just brought my grade up 2%. Oh, really? Yeah. This is my comeback flavor. Yeah, this is like, really cool. That's the cool thing. Oh, that's the cool one for, wait. We could get we get it out of 24. Okay. Yeah.
Hey, friends.
Yeah.
So who didn't take the quiz? Mia? Who else?
Okay.
Mia and Billy? Yeah. Okay, so take a clipboard there. Head out into the hall. Oh, you're really tall today.
Yes.
Yeah. Yeah, just go hang out in the hall, I guess. Or, oh, goodness gracious, goodness gracious. And so I struggled a little bit. Should I have given credit for humans? As the answer to the bonus question?
I didn't know.
What is it? Did you look it up?
No.
Oh, did someone tell you that?
No.
Who told you?
It's okay.
Oh. Yeah, I don't know. I didn't give point. I don't think I gave. Did I give you? I don't think I gave you a point. Did I give you a point for humans? You put humans and you put humans. You put humans. Two. Oh, now. If you end up meeting that point, I'm gonna give it to you. But I thought someone was gonna put virus. Is virus kind of a creature? It's not alive. Virus is not alive? No. That's it. What do you mean? I think it's like considered living things. What? Well, no, viruses aren't bacteria, they're separate. Yeah, bacteria are living things. Viruses aren't living? So you're saying if those rover that just landed on Mars, if they discovered there was a virus on Mars, like they would say there was life there? Well, I mean, I'm not a biologist. I have no idea. They don't let you because they can't self-replicate. They fire it. Oh, they gotta live on something? So I mean, if they found a virus on Mars, that would be the virus there. They can't just by cells. I don't know.
I'm not sure whether viruses are living
Oh.
It's a debate.
It's a debate. Wow. Okay. What do we call it? A creature? All right, so I'm not going to go over the answers to this because I just sent it to the folks that are online on the side they're watching right now. It'd be stupid for me just to go over the answers while they're taking it. I suppose you could send it to them, take a picture of your phone. But of course, as you guys all know, when you're online, you can do that all day long. But anyway, so do we have questions about anything? Let me tell you how the next week is going to unfold. Okay. We made the executive decision to not do all of these different partial fraction techniques. Part of that's because we're slightly behind where we should be. So I made that executive decision, which means that we're sort of done with the integration techniques. We've got U subs, integration by parts, trig subs, and partial fractions, right? Tomorrow and Wednesday, we'll talk about improper integrals, which that always gets thrown into this unit. It's not a technique of integration per se, but it always gets thrown into this unit. No, an improper integral is one where you have one of the bounds is infinity. So we'll do that on tomorrow and Wednesday, and maybe spill over into Thursday a little bit. But we're going to have a test on Monday, 1 week from today. Tomorrow we're going to have a little quick quiz on partial fractions, which should be really easy. Like you'll have 5 minutes to do it because it's. I mean, if you know how to do these partial fraction problems, like they literally can take 45 seconds if you use the shortcut, and that's all you have to know how to do it. So, that's that. Questions about anything? Problems you want me to work out? Open season. And I'll have some review for you for the test too. We'll compile some review problems. Yeah. Yeah, whatever. Yeah, so that one was. I knew you were going to have trouble with it. I mean, I gave you that one knowing that that was going to be one you were going to huh? Wait, how's this? What's going on with this? Okay, that's actually a partial fraction problem in disguise. It's 100% a partial fraction problem in disguise. And you're saying, no way. And I say, oh yeah, baby. So Nicole said, e to the x over e to the 2x minus e to the x, right? Well, the denominator, I'm going to factor out e to the x. So if I factor out that e to the x in the denominator, I got that, right? And maybe you're thinking here, oh, I can just cancel those e to the x's. You might be thinking that. Okay, but you actually don't want to do that. Because if you do, then you're just going to be left with 1 over e to the x minus 1, and we don't know how to do that. So what I'm going to do now is we're going to make a u sum. If I say u is e to the x, what's du? E to the x dx, right? So that's the numerator. So it ends up being du over u times u minus 1. And now do you see the partial fractions? So if I break this up, I have a over u plus b over u minus 1. Okay, so what's a? So 1 makes that 0, right? So plug 1 in. I'm sorry, 0 makes that 0. Plug 0 in for everything else, so that's negative 1. And what's b? 1 makes that 0, cover that up, 1 over 1. B is 1. So now I'm going to integrate this. So that's negative natural log of u plus natural log of u minus 1. And then I'll go back and resubstitute negative natural log of dvx plus natural log of dvx minus 1. And I'm going to simplify this because this is embarrassing to leave that written that way. If we leave something written like this, we should be embarrassed. The negative natural log of dvx is just negative x. Now I can't do anything with that the second term. Because I can't distribute that law. Oh, man. What's the derivative of tangent, man?
The derivative of tangent?
Yeah.
Oh, tangent x secant.
That's the derivative of secant.
Huh?
That's the derivative of secant. Yeah.
Yeah.
You did it right with the wrong derivative of tangent. Carrie, what was your question? Oh, plus chips. Yeah. So do you see, Nicole, how that ended up being like a partial fraction in disguise? The one right after that's the same way. I think the one after that was this. Right?
Yeah.
Now there's an easy way to do that one, and there's a more difficult way to do that problem. The easy way to do this problem is actually just to call 1 minus cosine squared sine squared. And now we're left with 1 over sine after you simplify, which is cosecant. And then, I know the antiderivative of that is negative natural log of cosecant x plus cotangent x. You don't need the partial fraction. But you could do that with partial fractions. Because you could say, hey, let u equal cosine of x. What's du? What? Negative sine of x. So that's negative 1 du over 1 minus u squared. Right? Which is negative 1 over 1 minus u times 1 plus u. And you can do partial fractions there. Now it's kind of interesting because when you go and do this, you get an answer that looks very different than the answer that we have on there. Very different. Like not even in the same ballpark. Let's do it. So what's A? What's A? 1/2? And what's B? One half again? Does everybody agree with that? None of it. So A is 1/2, B is 1/2? Okay, so now, what's the antiderivative? The antiderivative of this first term. I'm going to leave that negative right there. Tell me what the antiderivative of the first term is. Be careful. What is it, Samuel?
1 natural log of 1 minus 3.
I think it's negative 1/2 natural log of 1 minus 3. Why is that negative, Rick? Because of this right here. Okay? If off to the side you just did an integral 1 over 1 minus x, and you did that as a u sum, u is 1 minus x. du is negative dx. What's the antiderivative here? That's just straight 1/2 natural log of 1 plus u. Right? Now if I distribute this negative, I'm going to get 1/2 natural log of 1 minus u minus 1/2 natural log of 1 plus u. So okay, I go back and resubstitute. What was u? Forget cosine. Now, boys and girls, I want you to look at this answer right here and this answer right here. They don't look anything alike. But they have to be equivalent or differ by a constant. Are those equivalent? Well, I will say that this one right here isn't this the same as this? Because really that negative can make that whole thing to the negative 1. So that's why those are equivalent. Isn't this right here the same as this? And then that's also been equivalent to this. Whoops. Because to the 1/2, it's to be the whole thing to the 1/2 power. Right? So if these two are equivalent and they don't differ by a constant, if they're just straight up equal, then what's inside here has to equal that, which is what I have written right here. It's like a trig identity proof. Remember doing those last year? Yeah, I'm shaking his head in disgust. Didn't you prove that? If those are equal? I'm going to try it when you guys leave. For fun. I debated offering someone extra credit to prove it, but the problem is you could just cheat. That's what you do. You Google it. Photo math. Could you photo math that? I don't know how photo math works. I heard about photo math about 4 years ago, but when it first came out, I couldn't do calculus, but now apparently it can. But that, look, this right here isn't calculus, so those are equal. My guess is if you photo math that, it would try to solve for x. And then it would say all real numbers. If it's all real numbers, that means they're equal. For all values of x. That's what it means to be equal, right? If you were sitting back in Bridget's class, what would you do there? What would be a strategy? One strategy to prove that those are equal.
You convert secant x over sine of x, convert x of x over sine of x, or cosine of x over sine of x.
So you could do work on the left side, and you're saying, oh, I'm going to write this as 1 over sine of x plus cosine over sine of x, which means that's equal to 1 over 1 plus cosine of x over sine of x. Okay. Then what did you do?
Then you add those two, you do that, and then you, like, basically flip it to sine of x over 1 plus.
Yeah, so you do the arithmetic here.
You square the entire thing.
Whoa. I don't know about that.
Square them,
You can't just square something. We're not allowed to just square something. If I'm working on just that left side, I can't just square it because then it's not equal.
you can change the top to the square root of 1 minus cosine of x.
What do you mean?
Like, because sine of x is equal to 1 minus cosine of x. The square root of 1 minus cosine squared x.
Sine squared is 1 minus cosine squared. I agree with that.
So you can convert it to the square root of 1 minus cosine squared.
So you're telling me that this numerator is now this? Like that? I agree with that. Interesting. What period is this?
You get out at like 26.
Yeah, that's.
That's weird. Yeah.
Oh, I missed it. I don't have 4 or 5 on here.
Yeah, no. Maybe we got out at like 26.
4, 6, 7.
6, 7, I didn't care about because I don't have a copy. Yeah, I can't find it. What time do you think we get out of here?
I'm pretty sure it's 26. But I can know.
Yeah. What? Cosine to the 4th. What about it?
24.
It's what?
24 is when we get out.
So, Nicole caught something that I did wrong on that cosine to the 4th. Can I see that? See what? Oh, yeah. I forgot about that. This is going back a couple days. So if you remember, we got this. Like, if you go back and look at your integral of cosine to the 4th, it's kind of nasty. So what I forgot to do was when I put this 1/4, I didn't distribute that 1/4 across everything. If you look back at your notes, like when we did that, I didn't distribute that 1/4 across. But all it's going to do is just change a couple constants in your answer. But I'm not terribly concerned about that. I'm not going to ask you to do cosine to the 4th on the test, probably, so. But I certainly should acknowledge that I did screw that up. Daniel's still trying to figure that out over there.
Yeah, I know that, like, it's so close, it feels like it should be easy.
I'll be honest with you, I haven't worked it out. I mean, it just came up this morning. And we've concluded that they have to be equal or be off by a constant.
What's the sum of the thing with that multiple line?
What's the double angle formula that involves cosine? What do you mean? Cosine 2x equals cosine squared minus sine squared. Cosine 2x equals 2 cosine squared minus 1. Cosine 2x equals 1 minus 2 sine squared. You don't know those, Gavin?
Wow.
I'm gonna play around with that during lunch, and we may end up concluding that they are different by a constant. If that's the case, I'll feel like that was a lot of waste of effort. I can tell you right now, I'm a little concerned because this algebra here, going from here to here, easy. Going from here to here, easy. Going from here to here, easy. And going from here to here makes sense. Where I'm a little nervous now is how I'm going to get a square root in the denominator. Like, I get how we wrote sine of x is the square root of you can't square both sides. Because when you square both sides, you're assuming that they're equal. You're only allowed to square both sides of something when you have equality to begin with. So if you're trying to prove to me that these are equal, you can't just go and square both sides. You have to take one side and turn it into the other side, or take this side and turn it into the other side. Like, you can't just square both sides, because when you square both sides, you're using a property of equality that you're making the assumption that they are equal. Oh, I see it. All the distant buttons. Okay, so everybody agrees with what Samuel did there. That denominator right there is the same as the square root of that, is it not? That's stupid to write it like that, but it is true. And then, so I write that as one fat square root, then factor. Oh, this is so satisfying. And there you go. Billy's like, I don't know what the heck is going on here.
You got the square.
What?
You got the square on the bottom. The denominator.
Oh, right here. I'm in the second last step?
Yeah.
Yeah. does. I believe him. He's not making that up. He gets that. Because he knows where it came from. If you knew if you knew the context of that right there, Billy, you would get it. But you don't have the context. Like, the reason this is happening over here is because we did this problem right here 2 different ways. We got this answer for that one, and then we got this answer when we did the other one. And we had to show those 2 answers were equivalent.
So since they can be off by, like, could you add a subtractive however much you want, like as long as it's a constant?
Sure.
Okay. We kind of prove that later. Okay.
I'm going to give that to Chris, how this counts, or pre-count. It's kind of funny how it's not the, like, trig that caused that to be difficult. The trick that tripped it for me. Remember when I said, how am I going to get a square root on the denominator? Like, that's what I was, like, in my head, I was wrestling with. The trick was to think of the denominator as the square root of a perfect square. It was doing that. Once I saw that in my head, I knew this was going to happen. I mean, that only comes from experience, you know. Cool trick. Well, I was a little concerned that we were going to have to. I don't know. Do you have other questions? I will have some review problems for you before the test. Like I said, tomorrow we'll start improper intervals, and we'll probably have we're going to continue that on into Wednesday. And when we continue that on into Wednesday, there's probably going to be some sort of video or something. I have to think about how it's going to all go down. Because we just have such limited time now. I'm only with you for like 35 minutes or something crazy stuff. I mean, normally in proper intervals, it's like 2 class periods in normal periods. So we get out here at 26?
24.
24?
Yeah.
That's soon. I don't hear anybody out in the hall.
What? I might be wrong, but that's
4 seems like it would be in the running though, because 54.
Yeah, it's 54.
Yeah.
You were at 54 twice.
Yeah, it's 24. It
5, 6.
is 24.
Yeah, because 5, 6 would end at the same time as 6 L.
Yep.
Does anybody have scheduling sheets? You got to do that too. Yeah.
Yeah, but I don't know what
Yeah, we need to have a conversation about that. I can.
Can I come do it tomorrow?
Yeah, there's no rush. I mean,
Hammond, you come this far.
you know, that's a good question. Yeah, have you been it?
Yeah, we.
Yeah.